using the little sense of touch that he has left. His stories speak of heroes and heroines, mountains and lakes that he will never see, but that he dreams of like any other little boy. Meeting with Felipe deeply moved me, and also persuaded me to take a closer look at what is probably the greatest talent of our brain, the ability to learn. Here was a child whose very existence poses a challenge to neuroscience. How do our brains' cognitive faculties resist such a radical upheaval of their environment? Why could Felipe and I share the same thoughts, given our extraordinarily different sensory experiences? How do different human brains converge on the same concepts, almost regardless of how and when they learn them? Many neuroscientists are empiricists. Together with the English Enlightenment philosopher John Locke, 1632 to 1704, they presume that the brain simply draws its knowledge from its environment. In this view, the main property of cortical circuits is their plasticity, their ability to adapt to their inputs. And indeed, nerve cells possess a remarkable ability to constantly adjust their synapses according to the signals they receive. Yet, if this were the brain's main drive, my little Felipe, deprived of visual and motor inputs, should have become a profoundly limited person. By what miracle did he manage to develop strictly normal cognitive abilities? Felipe's case is by no means unique. Everybody knows the story of Helen Keller, 1880 to 1968, and Marie Ertin, 1885 to 1921, both of whom were born deaf and blind, and yet, after years of grueling social isolation, learned sign language and ultimately became brilliant thinkers and writers. Throughout this book, we will meet many other individuals who, I hope, will radically alter your views on learning. One of them is Emmanuel Giroux, who has been blind since the age of 11 but became a top-notch mathematician. Paraphrasing the fox in Antoine de Saint-Exupéry's The Little Prince, 1943, Giroux confidently states, "In geometry, what is essential is invisible to the eye. It is only with the mind that you can see well." How does this blind man manage to swiftly navigate within the abstract spaces of algebraic geometry, manipulating planes, spheres, and volumes without ever seeing them? We will discover that he uses the same brain circuits as other mathematicians, but that his visual cortex, far from remaining inactive, has actually repurposed itself to do math. I will also introduce you to Nico, a young painter who, while visiting the Marmottan Museum in Paris, managed to make an excellent copy of Monet's famous painting, Impression Sunrise. What is so exceptional about this? Nothing, besides the fact that he accomplished it with only a single hemisphere, his left one. The right half of his brain was almost fully removed at the age of 3. Nico's brain learned to squeeze all his talents into half a brain, speech, writing, and reading as usual, but drawing and painting too, which are generally thought to be functions of the right hemisphere, and also computer science and even wheelchair fencing, a sport in which he has reached the rank of champion in Spain. Forget everything you were told about the respective roles of both hemispheres, because Nico's life proves that anyone can become a creative and talented artist without a right hemisphere. Cerebral plasticity seems to work miracles. We will also visit the infamous orphanages of Bucharest, where children were left from birth in quasi-abandon, and yet, years later, some of them, adopted before the age of 1 or 2, have had almost normal school experiences. All these examples illustrate the extraordinary resilience of the human brain. Even major trauma, such as blindness, the loss of a hemisphere, or social isolation, cannot extinguish the spark of learning. Language, reading, mathematics, artistic creation, all these unique talents of the human species, which no other primate possesses, can resist massive injuries, such as the removal of a hemisphere or the loss of sight and motor skills. Learning is a vital principle, and the human brain has an enormous capacity for plasticity.